guys, and welcome back to this Python series. We are still talking about the object-oriented programming in Python, and from a couple of sections ago I told you that object-oriented programming is consisted of four main properties, which are abstraction, polymorphism, inheritance, and encapsulation. In this section we're going to be talking about inheritance in Python. The fun part about these object-oriented programming concepts in general is that it is not just applicable to the Python programming language. In as much as you understand what I'm going to talk about here, you can apply it to other programming languages, just changing the syntax to that which suits that of the programming language which you are working on. And I'll take my time to explain this concept so that you understand them very well. So this video might be lengthy. I want to wrap up this section on inheritance and then classes in general, so that when I'm done with that, we can then begin to work on a couple of projects and try to use everything we've done so far to build and automate things. So let us go further to see what we have. I'm going to just go through these slides I have here, so that after I'm done with the slides, we then go into code and understand these concepts better. Now, when we talk about inheritance, classes are not always written from scratch. It's just like we write one class and then another class inherits all the properties or the methods of the class we have written. From the previous section, we talked about this class called car, and then we created, we instantiated it, and then we gave in some methods inside of the class. Sorry, we initialized rather, not instantiated, and then we gave in some of the methods, and then we can try to create another class from this one, and then trying to create another class from this one. We should have all these properties as well. We are not supposed to begin to write out all of these again. So let's come back to this place, and then this is known as inheritance, where one class takes all the properties of another class. So the original class is called the parent class, while the class which is going to be created to collect all these properties of the parent class is known as the child class. So it is like a child-parent relationship. And then the child class inherits all the attributes and methods of the parent class, but it is also free to define new methods and attributes of its own. So let's explain what that means. We have a class which have already been created here. What we will do now is to create another class which should inherit all of these properties. So in that case, this will be the parent class and the other one will be the child class. Let's run through this slide. Then this is how we're going to be defining the method in the child class. So in the child class, we have to assign all the attributes in the parent class, that is inside of the init method. So when we do that in the init method, it will have the child class will now get all the properties of the parent class, and this is how we define a class in inheritance. We start with a class and then the name of the class, and then we create we make a parenthesis, and inside the parenthesis we put in the name of the parent class, and then we initialize, that is the def init, and then all the attributes of the parent class are added here, and then we use the super keyword, which I'm going to talk about when we go into code. We use the super keyword and then the init to pass in all these methods again, and then we can create an instance of it. So let us go into code now, and that's where we're going to do most of the stuff. So I'll run this again, this class which we talked about in the previous section, and then now I'm going to start creating the class that should be the child class, and let's call this electric car. And the electric car is supposed to have all the properties of the car class, so it is inheriting that. We have to pass it in, and then the next thing we're going to do is the init method double underscore init double underscore. We pass in the self, the make, these are from the parent class, the make, the model, and the year. So if we scroll up to this class, you see we have the same thing here. I just want to build a simple class that will just inherit all of this. I'm not going to add any new thing to it, so we can see that it works perfectly. Then the next thing we're going to pass in is the super dot init underscore the make, the model, and the year. So the super method here or function is a special function which helps Python to make connection between the parent and the child class. So this line here tells Python to call the init method from this electric car's parent class, which is the car class, and then which by convention give the electric car all the attributes of the parent class. So this can also be known as the subclass, while this one is known as the superclass. So let us take note of that as well. Instead of, sometimes some people will call this as subclass, while some people will call it as the child class, while this will be called the parent class or the superclass. So what happens here is just simple. We are passing in, remember here we have to put self.make and on and on and on up till self.here. This is where we stopped here, but you remember this one is added on its own inside the init class. It was given a value, so that is why we're not passing it in here. So but by just doing this, we have created an electric car class that has taken all the instances from this car class. So if we run this now, we have created a class called electric car which has all of these properties. So let us see that in action. I'll create an instance of the electric car class. Let's call this my new car, and it's going to be that is the electric car class, and then inside of it we want to pass in the make of the car, which is in this case Audi, and then we're also going to pass in the model of the car, which is e-tron, and then we're going to pass in the year, which is 2020. So if I run this now, we have created an instance of the electric car class. Remember, if you look at this, we don't have anything here. We are just inheriting all these features. So let us see if it works perfectly. Let's try by running one of these classes inside of this. Okay, to get the descriptive name of the class. So my new car dot get descriptive name. So if we run this function, we'll see we have the same name as it would have been if we just created an instance of the car class and we ran this. So you can see that with just this, we have created a new class that has inherited all of these. So you should take note of the catch here. When you create the name of the class, you pass in the name of the parent inside of this. I'm still repeating this so that you understand. When we begin to work on projects, I will not explain this further again, because I would believe that you have understood the whole concept. So after that, we define the init method, and then we pass in all the properties of the parent class inside of it, and we continue. Now moving further, let us see how we can begin to add in some other things in this class. I'll copy this class out of here again. I'll paste it below here. Now we want to add the size of the battery. It's an electric car, so it should have a battery. So let's see how we do that. If we want to get the value from when we instantiate the class, then we should add the battery size here, the same way we've been working on the other one, but I want to just create it and give the values inside of it immediately. So I'll just self.battery size, because that's what we're going to be using. Self.battery size equals 70. And then let's create another method that should describe the battery. So let's call this method describe battery, and then we're just going to pass in one parameter, which is self, because we want to make use of this. So what we are going to now do is we'll just print out the size of the battery in the car. Prints. So what are we printing? We're going to print that it should be an F string. This car has a self.battery size kilowatt hour battery. So we want to give in the size of the battery from here. So let's correct this. Now I can run this and I have to instantiate again, so I'll just copy this out of here and run this again, and then let's now print the car class, the battery. Let's try to print the description of the battery, which is my new car dot describe battery. So if we run this, you'll see it has printed what we have here. So this is something simple which we can do. Okay, now moving forward, there are a couple of other things we can try to do. Let's take, for instance, we want to override. Now when we talk of overriding, it means that we have a particular function or method inside of the parent class and we don't want that to be in the child class. So in order for us to make it unavailable or change it, we use override. That means whatever we have in the parent class is overridden by the new one we have given in the child class. So what I'm trying to say is that you can override any method from the parent class that doesn't fit what we are trying to model in the child class. So to do this, you define a method in the child class with the same name as the method you want to override in the parent class. So let us see how we can do that. I'll copy out this parent class again because I want to modify it completely. Let's paste it here, and then now I'm going to add a new method inside of here, which is fill gas tank, and then we want to give in, we are going to pass in the self, and I want to pass in another value which is the liters of the gas that we want to print something. So what we're going to print is you have less than left. So we want to print the amount of liters that are available in the car. So if I run this, I can now copy this again. I'm still using this, but now I should replace it. Instead of electric car, I'll replace it with just car. I want to show you this in action so that when we modify it, you can override it rather, which is the correct word. You should understand it. So if I now print my new car dot fill gas tank, and you see I have to pass in a value, let's say 2. Now it says you have less than 2 liters left. And now in the electric car, we don't need, because the electric car does not need gas, so we just don't need it. So let us see how we can override it. I'll copy the electric car out of here again. So I'll copy it out of here, paste here, and then what I'll do now is I'll create a new method which I want to override, which should have the same name as this one here. So I'll just copy this out of here and paste here, and it will only take one attribute, which is self. So, and then let's print out something. So we see this one, how it works. We say this car doesn't let's change this to double quote so as to fix this problem. Sorry. This car doesn't need a gas tank. So we're done with this. Now inside of I'll now create an instance of the electric car class. Let's call this one same name. So I'll just copy this again and paste here, but now it is an electric car. And then if we try to run the gas tank again, my new car dot fill gas tank, so you see we have this car doesn't need a gas tank. That means we have overridden what is in the parent class. I hope you understand what we're doing here. So this is what we call method overriding, and it is one concept which is available in object-oriented programming, even in other languages. So I believe you get the concept. Let's recap what we've done in this place. We talk about method overriding, and then it's about replacing whatever class we are having in the parent class with another thing. So in this parent class we have a method, and then this method is not required in this. It needed something else, so we have overridden it by just giving it the same name, and then that has been done.